there was a beam having a span of 20 meter. Having a span of 20 meter. And at 1/4 quarter span, right? There was a maximum bending moment that is calculated. Maximum bending moment section is this is 1/4, that is a 5 meter. So this is 5. Then what is the balance? 15 meter. Okay. Then they are asking, this is the midpoint of the beam. They are asking if there is a maximum bending moment at the left of the quarter point, then the distance between center of the beam and the center of the load. Okay. For calculating center of the load, first of all, you have to conclude how much load will be present left of the section, how much load will be present right of the section. Okay. The condition for getting maximum bending moment is, keep the load on the same ratio of section divides the span. So keep the load on the same ratio of, what is the meaning same ratio? The section divides the span 5/15. Yes or no? 5/15. In the same ratio, the load also shall be divided. Therefore, this is x, this is L minus x. L means what? Here 8 minus x. Because the length of the util is 8 meter. Right? So we can say this is x, this is 8 minus x. So if you simplify 8 minus x divided by x, which is equal to 3. So this is 8 by x, which is equal to 1, that is 4. So x equal to 2 meter. Now you got it, this x equal to 2 meter. So this x equal to 2 meter, then the remaining, this is equal to 3. Okay, total 5. So this is 5, then this also shall be 5. Total is 10, right? Midpoint. Now how much the load? This one is 6 meter. Total is 8. This is 2, this is 6. Then they are asking CG of the load and CG of the span. This is the CG of the span. What is CG of the load? CG of the load is somewhere here. Yes or no? So this is your answer. So CG of the load means from this point to this point is 4 meter. That is CG of the load 4 meter. This is 4 meter. In between these two, we know that 5 meter. Therefore, this answer is 3 meter. Okay. So answer for this question is 3 meter. They are asking CG of the load to the CG of the span. So this distance is 3 meter. Okay. Now next question. The simply supported bending moment at the central hinge of a 3-hinged arch is 36 kilonewton meter. The span and the rise at the hinges are so on and so forth. Then the horizontal thrust in the arch. There was a 3-hinged arch. They did not mention what kind of arch. So this is the 3-hinged arch. They are saying 3-hinged arch of 36 kilonewton moment, 36 kilonewton meter moment, which was applied on the hinge. The span is 12 meter. The central rise is 3 meter. Then what is a horizontal thrust? So actually, this question is not fair. This question is not correct. The question is wrong. The reason is, this is the hinged end. The hinged end will not take care of any moment. That is a basic concept of hinge. Okay. What is the basic concept of hinge? Hinge only transfer the shear force and bending moment or the kind of forces. But this one, the hinged end will not bear any bending moment. Also, The hinged end, on the hinged end, we can't apply a moment. Therefore, this question is, as per my understanding, this question is not correct. Okay. Now, so that's why I'm leaving this question. This question is not correct as per my understanding. Okay. Because the reason is, I justified the reason. At the hinged end, you can't able to apply a moment. But they said 36 kilonewton meter is applied on the hinge. So that's why this question is not fair. Okay. So you can just attend any one of the options in your examination. So they will provide you the mark. Okay. Next one is, the shape of the cable under horizontal UDL is parabola. See, there are two types of cable. A cable which is subjected to uniformly distributed load along the horizontal span. Along the horizontal span, this is the horizontal span. Then we will call it as this as the parabola. At the same time, there was a cable, and this cable is subjected to a UDL along the length of the cable. Then we can say this is the catenary. If the UDL is acting along the length of the cable, then we can say catenary. If the UDL is acting along the length of the horizontal span, then we can say it's a parabola. Okay. Next one. A cable of span L and central dip is subjected to uniformly distributed load of W per unit horizontal length. The horizontal component of tension in the cable is H, they are asking. See, there was a cable, span L and dip subjected to uniformly distributed load per unit horizontal length. So it is subjected to a load which is horizontal length. So that I can mark this. It is subjected to a load in the horizontal length. So if you see the free body diagram, because of this load, this end and this end are subjected to VB, and this is the HB, and this is the VA, and this is the HA. And this is the length of the cable. This is the central dip of the cable that given. Then they are asking, what is the horizontal component of the cable? So HA they are asking. For that, first of all, you have to calculate this one. Here the load is given W kilonewton per nanometer. Then what is this? WL by 2. Total load divided by 2, you will get a reaction. This is also W by 2. What is a W? Load into distance. Divided by 2, you will get a VA. Divided by 2, you will get a VB. Okay, because of symmetry. Then, to calculate this HA or HB, take moment about C. Okay, so we can write HA into summation of, not summation, moment about that point is equal to 0. Moment at C is equal to 0. That is HA into, assume anticlockwise is positive, HA into T minus WL by 2 into L by 2, force into distance L by 2, then plus W into L by 2 into L by 4, which is equal to 0. Therefore, after solving HA is equal to W L square divided by 8D. So answer for this question, now we got it. This is the B. W square by 8D. Okay. Now next question. A compression member has one end hinge and other end rigidly fixed against rotation. Oil buckling load is 120. What will be its buckling load if its both ends are fixed against sway and rotation? In the first case, they said one end is hinged and other end is rigidly fixed against rotation and away. That means this end is fixed and rotation. This end is rigidly fixed against rotation and translation. This is only for hinged. So for this, we know that P crippling is equal to 2 pi square EI by L square. So this is the answer. They said this value is equal to 120 kilonewton. And they are asking if both ends are rigidly held. Read the statement. What will be its buckling load if both ends are fixed against sway and rotation? Sway. Actually, this is sway, okay, not away, sway. So the answer is, for this case, P crippling is equal to 4 pi square EI by L square. So which is equal to, we can write 2 into 2 pi square EI by L square. So it's equal to 2 into 120. So therefore answer is 240 kilonewton. 240 kilonewton is the answer. So here I'm going to write some of the important extra formulas so that will be beneficial for you. End conditions. L effective. P crippling. One and both ends are pinned. L effective is equal to L. P crippling is equal to pi square EI by L square. Both end fixed. L effective is equal to L by 2. 4 pi square EI by L square. One end is fixed, other end is hinged. L by root 2. And this value is equal to 2 pi square EI by L square. One end is fixed, other end is free. 2L, this is pi square EI by L square. Okay. So this is important. You have to just keep in your mind. The next one. A horizontal semicircular beam of radius R, radius is R, fixed at the ends and carries a UDL of W kilonewton over its length. The bending moment at the fixed support is. They are asking the bending moment at the fixed support is a semicircular beam. Horizontal semicircular beam of radius R fixed at the ends. So this is the both ends are fixed. And it is subjected to a UDL acting throughout the span. And they are asking what is the moment at the ends. So this moment at the ends, this is the value W R square. You have to keep in your mind. This is the standard value. So this value and this is equal to W R square. Okay. Now, a cantilever beam of span L and flexural rigidity EI is subjected to a concentrated load W at a midspan. The slope at the free end is, so this is the beam. At a midpoint, there was a load. So we know that this beam will bend something like that. Up to this load, it will bend as a curve. Then it goes as a straight. It goes as straight. Now the meaning, this point is A, this point is B, this point is C. Now slope at B and slope at C, both are same. Why? Up to B, there was a straight line. Beyond C, so up to B, there was a curve. Beyond B, there was a straight line. How can we calculate slope at B? Draw a tangent at B. If you draw a tangent, the tangent will go something like that. Okay. Now this is the tangent. Now this tangent coincides with the straight line of BC portion. Therefore, This is the value, that is theta b, and this theta b and theta c both are same. Theta b is equal to theta c, both are same. What is the theta b? This theta b is equal to WL square divided by 2EI. So answer is WL square by 2EI. So WL square by 2EI is your answer. Okay. Now the next question is, a column of rectangular cross section, D units by 1 unit width, rectangular cross section and area is given. Okay. At the top is subjected to a load P. In addition to that is self-weight. The profile for uniform stress along its length. So along its length, how the profile you have to design. So this is the, for example, a bar. Okay. If you want to design a bar of uniform strength, then we have to design a bar in such a way that this is the parabolic, not a parabolic, I think this is the exponential curve. So design the curve, design this bar in such a way that exponential curve. This is the exponential curve. The top area is A2, this area is A1. Then we know that we can write A2 by A1. The final result is A2 by A1, which is equal to 1 minute. Is equal to okay, e power rho GL divided by sigma. So this is the formula. Exponential rho GL divided by sigma. Rho GL divided by sigma. Now A2 we can write, what is the A1? Initial cross section area they given D into 1. Therefore D into 1 into e power rho GL divided by sigma. So finally D into e power rho GL divided by sigma. So this is our A2 now. Okay. Therefore the answer for this question is this one. So here we taken as a weight density, but they given in terms of mass density. So we can write this as A2, which is equal to D into e power rho. Also you can write this is in terms of weight density, this is a mass density. Here L, but they given in terms of X. So divided by, sorry, D into e power plus rho X divided by sigma. And we can write here L is equal to X. The answer is here. Now, a threaded rod is placed inside a tube and fastened by nut at both ends. The pitch of the thread is P. For quarter turn, what is the advancement of the nut? The advancement of the nut is directly proportional to turn. We can write advancement of the nut, which is equal to turn, that is turn. Okay, which is the number of turn. I can write as a number of turn. While changing this directly proportional, then you have to put a pitch is the constant, into number of turn. Here P by, what is the number of turn here? Quarter, 1 by 4th only, even not a single turn, 1 by 4th. Therefore advancement is C. Okay. Now in a reinforced concrete beam, the stress in the concrete at the level of steel is measured as 6 Newton per millimeter square. The modular ratio between steel and concrete is 18. Then what is the stress in the steel? They said the stress in concrete at the level of steel is 6 Newton per millimeter square. The modular ratio between steel and concrete is 18. That is M is equal to 18, they said. What is stress at the level of steel? At the level of concrete? We know that sigma ST, which is equal to M into sigma C. So 18 into 6, therefore 108. Okay, Newton per millimeter square. So answer is B. Now, next question we can see. A square bar of 20 mm by 20 mm is subjected to direct tensile force. A square bar of size 20 mm by 20 mm, 20 mm by 20 mm subjected to a direct tensile force. Sigma x. Sigma x. What is the largest tensile force of the bar if it can sustain a shear strength of 100 megapascal? For this kind of arrangement, we know that tau max, maximum shear stress, which is equal to sigma x divided by 2. So this is 100, therefore into 2 is equal to sigma x. That is the largest tensile stress. The tensile stress is 200. Sigma x equal to 200. Therefore, answer for this question is 200. Okay. Next question is, for a overhanging beam, the expression for bending moment is given as 2.5 into x minus 3x squared divided by 2 kilonewton meter. Then they are asking the location of maximum bending moment. So there was a condition, that is a rate of change of bending moment is equal to shear force. When the shear force is 0, where bending moment is maximum. Okay. Therefore, in order to find out the maximum bending moment point, you have to differentiate the given bending moment value. Therefore, you can differentiate dm by dx, that is 2.5 x minus 3x squared divided by 2, which is equal to shear force. So it is equal to 2.5 minus 6x divided by 2, which is equal to shear force. Now you have to equate the shear force equal to 0. Therefore, 2.5 minus 6x divided by 2, which is equal to 0. Since bending moment is maximum, bending moment is maximum where shear force is 0. Therefore, the answer is 2.5, which is equal to 3x. So x equal to 2.5 divided by 3. So 2.5 divided by 3 at a distance, you will get a maximum bending moment. So answer B is correct. Now next question. The sum of moment of inertia of two mutually perpendicular arbitrary axes is always constant. Okay. So sum of, suppose this is the section. This is the section. Sum of moment of inertia of a rectangular section. This is xx and yy. Xx and this is yy. Moment of inertia about xx plus moment of inertia about yy is equal to one value. For example, a. Okay, this value will be equal to if you take moment of inertia about some other axis. For example, this is another axis, and perpendicular to this is another axis. Let us consider this is x dash, x dash, this is y dash, and this also y dash, and that also correct. Same ixx dash plus iyy dash is equal to a. That means any two mutually perpendicular axes, the moment of inertia is constant always. Okay. Next question. Radius of curvature is always d square y by dx square. So this is the answer. We know that the formula m by I is equal to f by y is equal to e by r. Okay, e by r. In that you have to get these two, so that m by ei, which is equal to 1 by r. Now this 1 by r is called it as radius of, so this whole term is called it as curvature. This whole term is called curvature. So this is equal to, we can write d square y by dx square, that is m divided by e. So d square y by dx square is curvature. So we can write d square y by dx square, which is equal to 1 by r, okay, which is equal to m by e. So answer for this question is a. Next question. The angular twist of a shaft of radius r mm and length L mm subjected to a torque of 700 kilonewton millimeter. Take G is equal to 70 gigapascal. So they given G is equal to 70 gigapascal. So we can take it as this is 70 into 10 raised to 3 Newton per millimeter square. Similarly, T is equal to 700, this is 700, okay, into 10 raised to 3 Newton millimeter. So we can write it. Okay. Now what we can do, so we can substitute the value in the partial formula, so that we know that the formula is actually there is some mistake in the question. This is not a 700, this is the 70. Okay, so this is actually 70. There's a mistake in the question. 70 into 10 raised to 3 Newton per Newton millimeter. We know that the torsional equation T by IP is equal to tau divided by R is equal to C theta divided by L. What is a T? You can equate these two, then only you can able to calculate the theta. T by IP is equal to C theta divided by L. Now here T value and G value both are same, so that you can ignore these two. 70 into 10 raised to 3. What is IP? Pi d power 4 into 32 divided by 32, right? It goes numerator. Next one is 70 into 10 raised to 3 theta divided by length. If you simplify this, 32 L divided by pi into 2r the whole power 4 is equal to theta. 32 L divided by pi into 2 power 4, 16 r, which is equal to theta. Therefore 2 L divided by pi r Actually, this is r power 4. Pi r power 4 is equal to theta. Therefore, this is the answer. Theta is equal to 2L divided by pi r power 4. Therefore, this is the answer.